Hello, Year 12s. I've had a few requests for a few exercises to be solved, or some extra explanations provided. So I've made this video, and I hope it's helpful for you with learning maths. Okay, so the content that we're going to cover in this video is on page 37 of the Theta textbook, exercise 4.05, and we're going to be taking equations that look like this. So there's a bracket with something raised to the power of 2, and we're going to be rearranging them so that x is the subject. So we're going to make x the subject of the equation. Okay, so that's the end goal, to get something that looks something like this. Alright, so before we begin, we need to know a few things about square roots. So I'm just going to take you through some basics. So something that we know is 64 equals x squared. So we all know the answer to this. It's 8. But how do you sort of show you're working? Well, in algebra, when the golden rule is to do the same thing to both sides. So generally we would show a square root on both sides. So if we take the square root of x squared, we get x, and if we take the square root of 64, if we put that in our calculator, we get 8. Now, some of you might know that there's actually two answers for the square root of 64, because while 8 times 8 equals 64, so does negative 8 times negative 8. That also equals positive 64. So actually, whenever you take the square root, you end up with two answers, which are either a negative one or a positive one. So generally what we do instead is, I'll show you over here, the same thing. We don't actually do the square root on both sides, we just sort of move the 2 over, and when it goes to the other side it becomes a square root. It's sort of like how if I had 2x equals 4 equals 3y, then we'd move this 2 to the other side. It's like it becomes a divide by 2, so we get 3y divided by 2. So in the same way, when you move to the power of 2 to the other side, it just becomes a square root. So you don't actually need to write x squared out again, you just put x equals square root 64. And the other additional thing that we do when we move a square root to the other side now is we put a plus and a minus beside it, because that'll show us that we got our two answers. So our final answer is plus or minus 8. So that actually means negative 8 and positive 8. Okay. So the other thing that we need to understand before we start these problems is back to our Year 10 quadratics. So this here is a quadratic that can be factorized, but it's actually a special quadratic because it ends up being what's called a perfect square. I'll show you how that works. So generally a quadratic is in the form ax squared plus bx plus c. So just to jog your memories, we want the factors of c to add to the factors of b. Factors of c add to b. So how does that work? Okay, so the factors are 9. There's only two sets, 3 and 3, and negative 3 and negative 3. So those are the two ways that you can multiply numbers together factors. Well, actually you've got 1 times 9, but we know that's not going to work. So 3 times 3 is 9, but also 3 plus 3 is 6, which is what we were trying to find over here. So actually the set of factors that we want are 3 and 3, not negative 3 and negative 3. Sometimes you do get negatives, and there's a question later on that'll show that. So when you've got two brackets that are the same, you can essentially rewrite it as x plus 3 in brackets squared. So another name for this is a perfect square. So if we were going to solve this problem from the start, then we could factorize this quadratic into x plus 3 squared. Okay. Now, the squared, we can get rid of that the same way that we got rid of the squared in the 64 equals x. So if these are good notes to take if you want to re-watch the video and copy them down, but just watch for now. So if we were to square root both sides, so both this side and this side, then the 2 would disappear and we'd just be left with what's inside the brackets. I mean, you could leave the brackets there, but they don't actually have any effect on the problem anymore. And then so that power 2 moves to the other side and it becomes the square root y, plus or minus square root y, because it's got 2 separate answers, right? Because we just took the square root of both sides. The next step is, well, we want to isolate x. We're trying to make x the subject. So we want to subtract 3 from both sides. We don't generally write that we've done this anymore. That's kind of a year 9 skill. These days we just move it to the other side and change the sign. So whenever something moves to the other side of the equals, you've just essentially added negative 3 to both sides. Okay, so that leaves us with a final answer. So this is the answer, but you can actually there's a better way to sort of write this answer. Like generally you want to have the majority of terms on the right, so this is the heavy side, and you want the left to just be a single term. So what I've done here is I've flipped it, and I've actually swapped the terms around. So that negative 3, I've put that out in front, and the other term, which is kind of confusing, but the plus and the minus is joined up with that square root, and that can be flipped to the other side, and that's still the same. Plus or minus square root y minus 3 is the same as minus 3 plus or minus square root y. But that's not. This is just a better looking. Yeah. So anything actually I've done in black is just good notes to be writing. So all of that. Right. Let's move on to another question. So in the textbook, this is question 4. Ugh. This pen doesn't work quite as well as I'd like it to, but it's okay. So this is another unfactorized quadratic. So factors of C that add to B. So 25, we should be thinking of square numbers, so 5 times 5 is 25, but also minus 5 times minus 5 is 25. So we can see that because we're dealing with a negative 10 this time, we're going to be using the negative 5s. So what we end up with is x minus 5, x minus 5. Because these are both the same, we can rewrite that as x minus 5 to the power of 2, because there's two things that are the same that are multiplied together. Okay, now we want to take the square root of both sides, so we're going to end up with square root y plus or minus square root y equals x minus 5. The next step would be to add 5 to both sides, or effectively move that take away that minus 5 and put it on the other side. So let's do that. Plus or minus square root y plus 5 equals x. And now our final step to tidy up our answer, we're going to have x on the left side. We're going to have the 5 coming first and the plus or minus square root y finishing up. And that's just a good way to express your answer at the end. Okay. So this one is a little bit different in that we've got this plus 4 here. Now it's very important with square roots that you can't take the square root of both sides at this stage because of this plus 4. It's not gonna have the desired effect. You have to isolate your term, which is to the power of 2, first before you can take the square root of both sides. So the first step in this case is to subtract 4 from both sides. So that's going to look like y minus 4 equals x minus 1 squared. So we've just moved that plus 4 term essentially to the other side. It's become a negative 4. Okay, now we're ready to do the square root of both sides. So this time the square root is going to go over all of the y minus 4. So what does that look like? I like to drag out the square root and then I put a little downwards line at the end of it, and that sort of just encapsulates the whole of what we're square rooting, and we avoid anything getting confused. So because we've moved the square root to the other side, we are just left with what's inside the bracket. I've forgotten to put the plus and the minus, that's also important. Okay, finally we have got to isolate our x, so we need to add 1 to both sides now. Oops, these are getting a bit out of order. Sorry about this. Okay, so if we added 1 to both sides, that would eliminate our negative 1 on that side, and it would drop it. Next to the square root. So it's outside of the square root. The plus 1 is outside, the minus 4 is inside. Okay, so last step, we're going to reorder it to make it look pretty. So we're going to have 1 plus or minus the square root of y minus 4. Okay. Last one that I'm going to do today is question 13 from that exercise 4.05. So this one looks way harder, but it's actually not too complicated, because what we've got here outside of our x plus 1 term is actually a quadratic, but not with x's but with y's. So our first thing that we're going to do is we're going to add 4 to both sides to move that negative 4 to the other side. So we end up with y squared plus 4y plus 4 equals x plus 1 squared. At this stage, we can factorize the y squared plus 4y plus 4 the same way that we factorize x's. It's just a different type of variable, but it's using the same factorization skills. So that's just going to be, well, 2 times 2 is 4, 2 plus 2 is 4, so this is going to be y plus 2 times y plus 2, which is essentially y plus 2 squared. Sorry, I'm just rushing a step. You generally write the other side of the equation, but no time for that. Okay, so that step there was factorizing our y terms. Okay, now we've got our y's isolated in a square root, in a power 2 term, and we've got our x's isolated in a power 2 term. So now we can square root both sides, and it's just going to eliminate those two power 2's. So square root both sides, we're going to get y plus 2 equals x plus 1. The point of these problems was to isolate x, so our final step will be to subtract 1 from both sides. So we're going to end up with y plus 1 equals x, which we can rearrange to x equals y plus 1. Okay, that's the end of the video. I hope you enjoyed it and hope that made sense.